Okay, so we already did example 1. Now on to example 2. Sammy conducts an experiment with 3 quarters. He counts the number of heads and tails for each flip of the 3 quarters. Sammy records the results in the table below. So this first row in the table is telling us that he got heads on the first coin, heads on the second coin, and heads on the third coin 10 times. Then heads, heads, tails, he got that 15 times. Heads, tails, tails, 18, and tails, tails, tails 7 times. So according to his table, what is the probability of flipping 2 heads and a tail? What is your answer as a decimal? Okay, so this time we're looking for the probability of 2 heads and a tail. So 2 heads and a tail here, and it says 15 times. So the probability of heads, heads, and a tail is 15 times. But we know for probability, you have to put what you're looking for on top over the total. So let's find the total. 5 plus 8 is 13, plus 7 is 20. So 0 down here, 2 up top, 2, 3, 4, 5. So he flipped the coin 50 times. And they want our answer in decimal form. So to get decimal form, we can either simplify and then do top and bottom out. So let me show you that. So I know I can divide it by 5, divide by 5. I get 3 over 10. So 3 over 10, you can either do top and bottom out, or you should know that if a 10 is on the bottom, it means it's in the 10th place, and it is 0.3. So 0.3 is the probability, or you could do 3 divided by 10. You'd put your decimal there. This is 30. 3 times 10 is 30. Oops, there. Okay, so the second one says, how does the experimental probability compare to the theoretical probability of getting 2 heads and a tails with 3 quarters? Okay, so theoretical of getting 2 heads and a tail. Okay, so probability of getting the heads is 1 heads over 2 sides of a coin. Probability of getting tails is 1 tail, 2 sides of the coin. So we're talking about 2 heads, so heads, then heads, and a tails. So heads is 1/2, tails is 1/2, and heads is 1/2, heads is 1/2, tails is 1/2. So you have the probability of each of the items, and we know that we multiply them. So 1 times 1 times 1 is 1, 2 times 2 is 4, 4 times 2 is 8. So 1 over 8, but to really make the comparison, we need to turn it into a decimal. So if you guys don't know what 1 over 8 is as a decimal, which we really should have that memorized by now, but 1 times 8 is 8, subtract 2, 22 times 8 is 16, 40, and 8 times 5 is 40. And so that means that 1/8 equals 0.125. So the experimental probability in this situation of 0.3 is greater than the theoretical probability. So it actually happened more frequently than it should have if all of them were equal. Okay, so moving on to example 3. Xavier rolls a die and flips a coin 20 times. The results are shown in the table. So here he rolled and he got 1, and then tails, 4, then heads, 6, then heads, 2, then heads. Okay, so based on the result of the experiment, what is the probability Xavier rolls a 4 and flips a heads? Hint, highlight all the results rolling a 4 and flipping a heads. So let's go through. We have 1 in tails, we have 4 in heads, 6 in heads, 2 in heads, 1 in tails, 2 in tails, 3 in heads, 6 in tails, 5 in heads, 4 in tails, 2 in tails, 3 in heads, 6. All right, I'm going around. Here's another 4, and there's 4 in heads. So the probability of getting a 4 in heads, well, it actually happened 2 times. So what we're looking for goes on the top, and then on the bottom's our total. Well, there's 1, 2, 3, 4 by 1, 2, 3, 4, 5. So there's 20 boxes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh. Sorry, it moved. Okay. Anyways, there's 20 boxes. If you count them or if you multiply, either way, you'll get the same answer. My computer's going a little crazy. Okay. So then we have 2 over 20, but can we simplify? Yes, we can divide them both by 2, divide by 2, and we get 1 over 10. Wow, it's chaotic. Okay. So then it says, how does the experimental probability compare to the theoretical probability? So the probability of getting a 4 on a dice. So how many 4s are on a dice? Ready? 1, 2, 3, 4, 5, 6. There's 1 4 out of 6 sides. Oh my goodness gracious. I just did what you guys do all the time. Wow. Sorry. Equals 1 4 out of 6 sides. And then the probability of flipping a heads. We either have heads or tails. So heads, the probability of heads we know is 1/2. So we're going to multiply our two probabilities. 1 over 6 times 1/2 equals 1 over 2 times 6 is 12. So 1 over 12. So is 1 over 10 greater than or less than 1 over 12? Well, this is saying essentially that our pie is cut into 10 pieces, and this one's saying our pie is cut into 12 pieces. So if it's cut into more pieces, you get a smaller sliver of pie. So the theoretical probability was less than, right, the experimental. So 1 over 10 is the experimental. That was greater than 1 over 12, which is the theoretical. All right, now you are going to move on to your independent practice.